Okay, so we've been talking about how to perform editing using QGIS, and I just want to use the knowledge we've gained so far to discuss how we could proceed with creating a base map in a scenario where you're running a project and you might only have the coordinates of your study area or a study area polygon. I just want to walk through the entire process of creating the um, study area base map, okay, using the base coordinate information that you have. And so I'm going to be working with the data from our project folder from another area called the Adazi area. And so I'm just going to create a link to that directory for now. And so the study area is from a place called Adazi in southeastern Nigeria. All right, and that's going to be our focus area for now. And that study area contains a um, number of folders. Okay, it contains a features folder which contains a geo package where we're going to keep our features for the base map. It contains a spreadsheet which contains outcrop locations that maybe represent latitude and longitude values that you have gathered from the field. There's also a raster elevation base map a raster base map that contains the base map data you may probably have from your field studies, maybe a scan map that's been on georeference but contains features from your field trip. And then I've added this folder to support in the creation of the symbology for the map. And so in QGIS, we're going to be working from a blank project to explore how we can go about doing this. But the first thing to do is to explore the outcrops folder so that we can understand the scenario in which we are working with. So I have this bedding spreadsheet here open, which contains a number of sample fictitious location points that you might be have created from your field studies. This contains a location ID field with that's identifying the number of locations you have. So I can see that there are 7 um, locations currently, and I've given each one a name, okay, which I'll use to identify each location. And so in for each location there is a latitude and longitude value. And so you might have gotten this from your GPS readings, all right, if you're using a handheld GPS. Um, and in the later section of this course, we're also going to be talking about how we can work with a modern GPS GIS integration, which makes use of a field mapping application. And so the first thing we'll do is to calculate the latitude from these 3 values. Okay, so our GPS readings includes a degree reading, a minute reading, and a second reading. And also on the longitude side, we have a degree reading, minute reading, and a second reading. So we calculate the latitude and longitude values for both using this spreadsheet, and then we'll create a new table appending the other features. Okay, we'll also be calculating the strike from our deep direction. Okay, assuming you measure the deep direction in your field trip, you're going to be calculating the strike because that will be used in the symbology and mapping process. So um, to calculate the latitude from the degree, minutes, and seconds, we use a formula which is the degree value, all right, plus. So we know that there are 60 minutes in a degree, so we'll have to divide the minutes value by 60. So essentially, we are going to be converting all values to degrees, which means that since there are 60 seconds in a minute, then there will be 60 by 60 times 60 seconds in a degree, which is the second value, all right, divided by 3600. And so I'll press enter, and that will calculate the latitude for the current location in decimal degrees. All right, so that is the latitude for this. So I'll just extend this to the other locations. I'll do the same thing for our longitude value. And so for our longitude, we are calculating longitude in degrees, which is G2 plus H2 over 60 plus I2 over 3600. And so we'll do that here as well. And so right now, these are giving us the reference by formula, but I want this to give us the reference by text only, because when we import this into our GIS, we do not want the values to be referencing a formula. I want to have the values the way they are. So I'll insert a new column here. I'll call this latitude. Alright, and I'll insert another column here. I'll call this longitude. And so I'll copy these values and paste them as values into this location. So I'll paste them as unformatted text. So that gives us the actual values and not referencing to a formula. So I'll do the same thing here. Okay, and I'll save this spreadsheet as outcrops after. So I'm working using LibreOffice, which is a open office and spreadsheet application. So we are also going to be using this to work with the bedding symbology. So at this point, I can remove all these three columns, all right, and also these three, leaving me with the columns for only latitude and longitude. Alright, so at this point we want to calculate our strike, and the reason why we're calculating our strike from the dip direction is because from field mapping we know that our strike is 90 degrees from the dip. But if we have a strike value here, okay, if we take our when we are symbolizing our bedding symbol, we want to make sure that the bedding symbol follows the direction of the strike. All right, now this is known as the dip direction, and this is the strike direction. So we want our rotation, okay, of our bedding to follow the direction of strike. So we don't want it to follow the direction of the dip, okay, because the bed could be dipping in either direction. We want it to follow the direction of strike. So if we take the strike readings, all right, we might be taking this reading instead of this one, and so that might be problematic knowing which direction exactly is the strike. But once we know the dip direction, then we know that the strike direction is always going to be 90 degrees from the strike, okay, and so we can come up with a specific formula for working with the strike. So we say that let the strike be equal to the dip direction minus 90. And the reason why I'm using minus, okay, instead of plus, so that when we are plotting our values in the when we're plotting our strike symbology, our bedding symbology, we do not move past 360. All right, because 0 is also coincident with 360, so we prefer to use minus, okay, so that we are always below 360 regardless of the value of the dip direction. All right, so with doing this, we now have a much more concise value for the strike. And so just like the other fields, I also create another column for the strike. So we have all our values now, and then we can now proceed to bring these locations into our GIS. So I'm going to close this window now and go to QGIS. And so under our outcrops folder, we now have two sheets, the outcrops before and the outcrops after. I'll bring this after sheet into the project, okay, and I'm also going to bring in the project boundary layer so we have an understanding of our study area. I'll quickly symbolize that to show our project extent. I'll call this the Adazi project. So there are a number of project formats we can use to save. QGIS comes with the XML project format, which is the raw QGIS project specification, which could be used by multiple applications. And this bundled format comes with a number of bundled files that could be used to work on the project file in case it gets corrupted. So I can either save it with QGIS format or specifically choose each one you want. So by default, this will choose QGZ over QGIS, but you can also change the setting in QGIS. Alright, so we have our project set up. Next thing we're going to do is to bring in our points into our project using a geoprocessing tool. Okay, so to get to the processing tools, we'll use the processing toolbox panel, which you can click bring up from here. And so I'll go to a vector creation toolbox, which allows me to create vector point features. All right, and I'll say create point layer from a table. So when I double click this, the window comes up, and then I'll make our bedding the input layer. Okay, our bedding table. Now the X field corresponds to our X direction, okay, and the Y field corresponds to the Y direction. So we know that the longitude values, okay, increase along the X axis, while latitude values increase along the Y axis. So for the Y, we'll choose latitude, and for the X, we'll choose longitude. Alright, so on the X field, we'll select longitude, and on the Y field, we'll select latitude. We do not have any elevation value currently, and at this point, we'll just create the points layer into a temporary layer. And so now we have our points brought into table, okay, into QGIS. And if I explore the attribute table, I can see all the values from the spreadsheet brought into the table. So I can make this a permanent layer. Let me quickly rename this. So right now our points have been saved. Okay. Alright, so the next thing we're going to do is to symbolize these points so that they look like bedding features. And so to do that, we're going to work with a graphic, okay, because QGIS allows us to work with SVG graphics, okay, in styling that. So if I go to the layer styling panel, I can style this point, okay, the simple marker point using a number of marker styles. Alright, so the simple marker just gives me a simple round marker, which I can also change, okay, by selecting any other graphic here that I want to use. Okay, but I want to use an SVG marker, which now allows me to bring in an SVG image that I can use to style the marker symbol. And so when I select SVG marker, QGIS prompts me to select an SVG file. Okay, so I can come down here and select an SVG file. And so if I want to select an SVG file, I can come here to this box here and select an SVG file of my choice. But before I do that, I have to create a sample SVG file, okay, in LibreOffice. So I'll search for LibreOffice Draw. It's an application from the LibreOffice suite of applications, okay, that allows us to create graphic items, and it's also open source, by the way. So with this, what I can do is create an SVG image. I want to create an image for um, a bedding symbology. So I'll join two lines together. Okay, and I'll group them. Alright, so I will right click and select group. And I also give them a color of black. Alright, and and if I'm comfortable, I can also increase the line width a little. Or increase the line thickness. Okay, so if I'm comfortable with this, I can export this as an image. Alright, so I would select image, select the graphic, okay, and go to file and select export. Okay, and I'll say SVG. I'll ensure that my selection being exported. I'll go to my SVG folder in my project, and I'll put that there. I'll call it bedding.svg, and so that will export this selection as an SVG file. So I can also explore. So if I also want to work, I can also save this file as for reuse later. Alright, in my folder. Okay, so I can close this now and explore my SVG marker in something like Internet Explorer or Edge. So while that is loading, I'll bring in that SVG marker into QGIS. Bedding.svg. As you can see, the marker is showing up here, but it's still quite small. So I'll select the marker and I'll increase the size of the marker. First of all, I'll change its color and then increase the size. And so you can see the marker is beginning to show up in my map where I have the points. I can give the marker a size of 8, okay, or if that is too big, 6. Alright, so one more thing I can do is for the SVG marker, I can increase change the stroke color. Okay, so this is coming as an SVG image. So any marker specific design you want to do, you have to do that in the drawing application. Alright, so if you also want to add, so what I want to do is to make sure that the point, the intersection of dip and strike lines are intersecting with the crosshair center point. So what I'll do is add an offset in the x-axis, okay, so that intersects, and I'll add a little increase offset in the y-axis. So now my markers are correctly positioned in that direction, so I can save my project at this point. So I also want to apply a rotation on my marker, okay, so that my marker will be rotated along, okay, the direction of my strike value. So I would use a rotation expression, alright, in QGIS. So I would come here and edit this expression for the rotation, and I'll say let the rotation be equal to, alright, a field value called strike. Okay, so I'm getting an error at this point that my rotation expression is invalid. I will attempt to explore this and see if I'm getting any response. Let me try to see if it works. So my I'm still getting an error. Let me clear this. And alright, so my expression for the rotation is now taking its values from the strike, and I can see a preview of what the value is at this point for station 1. So I click OK, and now my strike is rotated in the direction, okay, of my strike attributes. Alright, and since my dip direction is 90 degrees from my strike, okay, I can see my dip direction in the direction it is meant to be. So I can also QC that value, okay, by looking at my attribute table, and where I have an attribute of dip direction of 265, I can zoom the map to that feature, and I can see over here that, okay, selected in yellow is the dip direction of 265, and the strike value in the negative minus 90, which is pointing downwards to 175. Alright, so I am comfortable with my attribute, and I can clear the selections, okay, and save my styling. So I have my bedding, and the next thing I want to do is to label them, okay, okay, so that I can see the deep amount values. Okay, and I have this deep amount field where I have the deep amounts in my attribute table, so I can use that to label my points. So for the points layer, I'll go to the label section and select symbol labels and label using the deep amount field. Now I can see deep amounts at the various locations. Alright, so I'm just going to do a little bit of work on the labels to make them appear a little bit more clearer. Okay, so having brought in the labels, I'm going to bring in this raster map that we'll be using for the creation of our base map. Now right now this map has not been georeferenced. Okay, so we're going to explore the georeferencing process using the map. First of all, bring it to the bottom, and as you can see, there's a question mark here showing that there is no current spatial reference for the base map. So I'll zoom to that layer. Alright, and we can see where our map covers. Now this map contains some simple features like roads, towns, and rivers, and also some sample geology that we can use to explore how we can create a base map. And I'm just going to run through some of the basic workflows that you're going to need to be able to digitize this scan map to work okay in your project use case. And so the first thing we'll do is to create layers, feature layers for each of these thematic data groups. The first is we have geology polygons, okay, which are given in this map. As you can see, the geology polygons and also some included geology polygons. We have points showing places for schools and other places. We also have road line features, river line features, and a lake body of water feature for our study area. I'm also going to bring in the elevation raster for the study area into the project so we can see the elevation extent for the study area. And I'll give that a basic styling so that we can see the elevation extent for the region. So let us run through the georeferencing for this layer. So to do that, I'll go to layer, georeferencer, and so I'm going to work on this georeferencer and georeference the layer. And when we come back in the next video, we are going to be working on performing edits on the base map.